Our unseasonably warm weather is also feeding the biggest algae bloom on the West Coast in decades. The toxic levels are already extremely high in the States, and as CTV's Mi Jung Lee reports, fisheries in BC are now on high alert.
Toxic, harmful algal blooms are a major global concern, and with increasing ocean temperatures, they are on the rise. Shellfish such as mussels feed on such toxic algae and accumulate toxins in their systems. Consumption of such toxic shellfish can lead to severe gastrointestinal disorders, paralysis and even death. Knock-on effects include the closures of coastal fisheries and massive shellfish recalls. Marine toxins have an estimated global economic impact of $4 billion per annum. My name is Daniel McPartlin. I'm a research scientist in the Applied Biochemistry Group in DCU. My work aims to address these issues by developing a biosensor, a type of biological test that will detect the toxic algae and their toxins in the sea. The issue with current monitoring programs is that a sample must be taken from the ocean back to an onshore lab to be tested on expensive equipment by trained personnel with a high cost and a relatively long turnaround time of several days. My biosensor is different. It is a lab on a disc. On the surface of this disc are antibodies, specialized proteins made in the body that can bind to virtually any molecule. When a seawater sample is placed onto the disc, these antibodies will bind to any algae and toxins present and will then measure their concentrations. I aim to deploy this biosensor onto a marine monitoring buoy in the sea. There it will autonomously take seawater samples and measure algal and toxin levels in real time. This data will be relayed ashore and will warn coastal fisheries of blooms as they are taking place, so that they can avoid harvesting contaminated shellfish. This will help to ensure food safety and may save millions of euros each year. Thank you.